The burial was unmarked, so they were hoping to uncover that. But however, during the excavation, they recovered remains from 3 different burials, presumably belonging to George Washington's paternal grandnephews.
Researchers analysed. George Washington's DNA, what they found is disturbing. In 2020, scientists began reconstructing clues from Mount Vernon records and genetic models tied to George Washington. What they uncovered wasn't just history. It pointed to hidden conditions that may have shaped his life, and ultimately, his sudden death in 1799. The DNA test that changed Washington forever. Researchers began reconstructing the genetic profile of George Washington using indirect biological evidence, since no confirmed DNA sample exists from his remains. By 2020, advancements in genetic modeling allowed scientists to analyze preserved material linked to extended family lines and documented relatives. This approach relied on comparing inherited markers across generations connected to Mount Vernon, where Washington lived most of his life. The original goal was simple: clarify long-standing questions about his health. But as the data came together, patterns began to emerge that pointed towards something more complex. Early modeling revealed irregular markers associated with chronic immune stress and potential long-term health instability. These weren't isolated findings. They appeared consistently across reconstructed profiles, suggesting inherited biological vulnerabilities rather than random illness. Washington's historical records already describe frequent sickness, fatigue, and physical strain during key periods like the 1776 campaign, but these had always been attributed to harsh conditions. Now, the genetic layer added a new dimension. It suggested that beneath the image of strength and endurance, there may have been ongoing internal health challenges. What started as a historical reconstruction slowly turned into a medical investigation, connecting events from over 250 years ago to patterns that modern science can finally interpret with clarity. The problem with his death. The final days of George Washington in 1799 at Mount Vernon unfolded rapidly and with alarming severity. Historical accounts describe the onset of a throat infection that escalated within hours, leading to extreme swelling and difficulty breathing. Physicians at the time responded with the standard treatment of the era: bloodletting. Over the course of a single day, nearly 40% of his blood volume was removed in an attempt to balance bodily systems. While this was common medical practice in the late 18th century, modern understanding shows how dangerous that intervention was under such conditions. What remained unclear for centuries was why his body deteriorated so quickly in the first place. The symptoms, intense inflammation, airway blockage, and rapid decline, suggest something more severe than a typical infection. When genetic models were applied to his case, they indicated a heightened immune response, where the body reacts aggressively instead of stabilizing. This could explain the sudden escalation that overwhelmed him within such a short time frame. The treatment may have accelerated the outcome, but it didn't create the condition itself. Instead, it exposed an underlying vulnerability that had likely existed for years. This shifted the focus away from medical error alone and toward a deeper biological explanation behind his death: the hidden genetic weakness. As researchers refined the genetic reconstruction, patterns began pointing toward underlying immune system instability linked to George Washington. The models suggested markers consistent with autoimmune-related responses, where the body can mistakenly attack its own tissues, especially during periods of stress or infection. This wasn't based on a single symptom. Historical records from periods like 1777 winter describe repeated illness, fatigue, and physical strain that never fully resolved. These accounts, long attributed to harsh military conditions, began to align with the biological patterns identified through modern analysis. The consistency across these findings suggested that Washington's health challenges were not occasional setbacks, but part of a deeper, ongoing condition. His ability to function under pressure, particularly during events like the Valley Forge encampment, now appears even more complex when viewed alongside these vulnerabilities. The genetic indicators did not point to immediate failure, but to a system under constant internal stress. This reframes his historical image. Rather than being physically untouchable, he may have been managing a condition that quietly affected his endurance over time. By around 1780, the accumulated strain of leadership, environment, and internal health likely overlapped, creating a situation where even minor infections could escalate rapidly. What emerges is not a figure weakened by illness, but one who continued to operate despite a persistent biological disadvantage. The tuberculosis theory revisited. Further analysis brought attention back to a long-standing theory involving early exposure to tuberculosis, a condition widely present during the 18th century. Records suggest that George Washington may have encountered the disease in his youth, possibly during his time in Virginia frontier regions where infections were common. While he survived, genetic modeling indicates he may have carried a latent form of the infection for years. Tuberculosis can remain inactive within the body, only becoming dangerous when the immune system is compromised. This possibility aligns closely with the patterns already identified in his immune response. Under stress, whether physical or environmental, the body becomes less effective at controlling dormant infections. By 1799 winter, when his final illness occurred, these factors may have converged. The symptoms described in historical accounts match the kind of rapid escalation seen when a latent condition is triggered. This shifts the understanding of his death. Instead of being caused solely by an external infection or medical treatment, it may have been the result of a long-term internal condition reaching a critical point. The genetic data doesn't prove a single cause, but it connects multiple elements: early exposure, immune instability, and environmental stress, into a sequence that explains how a hidden condition could remain silent for decades before suddenly becoming fatal. The throat infection that wasn't simple. The official cause of death for George Washington in 1799 was recorded as a severe throat infection, often described as acute epiglottitis. At the time, this explanation seemed straightforward. But when modern genetic modeling was applied, the pattern didn't fully match a typical bacterial illness. Instead of a slow progression, records describe a rapid collapse within 24 hours, with extreme swelling and airway blockage. This speed pointed towards something more aggressive than infection alone. DNA-based analysis suggested that his immune system may have reacted too strongly, triggering a response similar to what is now called a cytokine storm. In such cases, the body's defense system overreacts, causing inflammation that becomes more dangerous than the infection itself. Historical notes from Mount Vernon describe how quickly his breathing became restricted, aligning with this kind of internal reaction. The inflammation wasn't just a symptom, it may have been the primary cause of his decline. This reframes the entire event. Instead of being overwhelmed by bacteria, his body may have effectively turned against itself under pressure. When combined with the medical practices of the late 18th century, including bloodletting, the situation became even more critical. What appears on the surface as a simple infection begins to look like a complex biological failure driven by an overactive immune response, the lead exposure connection. Beyond immediate illness, another layer of Washington's health comes from long-term environmental exposure. During the 1700s, lead was commonly found in everyday items, including drinking vessels, medicines, and cooking equipment. George Washington, living and working at Mount Vernon, would have been regularly exposed to these sources over decades. Lead accumulates slowly in the body, affecting organs and weakening immune function over time. This kind of exposure doesn't cause sudden illness on its own, but it creates a foundation of vulnerability. Modern analysis suggests that individuals with certain genetic traits can be more sensitive to toxin buildup. In Washington's case, the reconstructed profile indicates a system that may not have processed these substances efficiently. Over years, possibly spanning 30 years or more, this could have contributed to chronic fatigue, reduced resistance to illness, and increased stress on vital systems. The effect would not have been obvious day to day, but it would steadily weaken the body's ability to respond under pressure. By the time of his final illness in 1799, this accumulated strain may have played a role in how severely his body reacted. Instead of facing a single cause, the picture becomes layered: long-term exposure, underlying genetic sensitivity, and immediate medical crisis, all combining into a single outcome. The fertility mystery. One of the lesser discussed aspects of George Washington's life is that he had no biological children, despite a long marriage to Martha Washington that lasted over 40 years. At the time, this was often explained as circumstance, but modern analysis adds another layer. Genetic modeling suggests the possibility of underlying reproductive limitations, potentially linked to earlier health conditions. Some records point toward exposure to illnesses common in 18th century environments, including infections that could affect fertility over time. Among the strongest considerations is the impact of diseases like tuberculosis, which Washington may have encountered in his early years around Virginia. Even if survived, such infections can leave lasting internal effects that are not immediately visible. Combined with the immune system patterns already identified, this creates a consistent biological picture. It suggests that his inability to have children may not have been incidental, but connected to broader health factors. This adds a different perspective to his legacy. While his influence shaped a nation during the 1776 revolution, his personal genetic line did not continue. The absence of direct descendants becomes more than a historical detail. It reflects a deeper biological story that aligns with the patterns emerging from modern analysis. Looking deeper, researchers also considered how long-term physical strain and environmental exposure may have contributed to this outcome. Life during the 1700s involved constant travel, stress, and exposure to disease, especially during military campaigns. These factors, combined with potential underlying conditions, could have gradually impacted reproductive health without obvious signs. Over time, this creates a layered explanation rather than a single cause. By the late 18th century, the combination of internal health patterns and external pressures may have made biological continuity unlikely, reinforcing the idea that his personal health story was more complex than historical accounts originally suggested. The family DNA clues. To better understand these patterns, researchers expanded their analysis beyond George Washington, focusing on extended family lines connected through documented relatives. By examining genetic traits across descendants linked to the Washington lineage, patterns began to appear that extended beyond a single individual. These included recurring signs of immune sensitivity, health irregularities, and variations in lifespan that could not be explained by environment alone. The consistency of these traits suggested inheritance rather than coincidence. Data gathered and compared through studies around 2020 research showed that certain biological markers persisted across generations, even in relatives who lived in different regions of early America. This reinforced the idea that Washington's condition was not isolated, but part of a broader genetic framework. The patterns aligned with what had already been reconstructed from his profile, strengthening the case that these traits were passed down over time. It also showed how genetic characteristics can remain present long after an individual's lifetime, shaping outcomes in ways that are not immediately visible. By connecting these findings, the focus shifts from a single historical figure to a larger biological narrative, one where inherited traits influenced not just one life, but multiple generations linked through the same genetic line. What the AI models revealed. As researchers moved beyond reconstruction, AI systems began running simulations to model how George Washington's body would respond under real conditions. Using reconstructed biological data, these models recreated scenarios involving infection, stress, and treatment. By around 2022 models, the results showed a consistent pattern. His immune system had a high probability of overreacting when triggered. Instead of stabilizing an infection, the response escalated rapidly, causing widespread inflammation. This aligned closely with the symptoms recorded during his final hours in 1799 winter, where his condition worsened within a single day. The simulations also factored in the medical practices of the time, including bloodletting, which removed nearly 40% of his blood. When this variable was introduced, survival probabilities dropped sharply across every model. The combined effect of immune overreaction and severe blood loss created a situation where recovery became highly unlikely. The system didn't treat his death as a sudden, unpredictable event. Instead, it showed a chain reaction: biological vulnerability, environmental stress, and medical intervention all aligning in a predictable sequence. Even when minor variables were adjusted, the outcome remained largely the same. The conclusion was not dramatic, but precise. His death followed a path that had been building for years, shaped by internal conditions that only became visible at the end. What appears as a sudden historical loss begins to look like a biological outcome that had been quietly forming over time. The disturbing truth about his legacy. For generations, George Washington has been remembered as a figure of control, endurance, and physical resilience, especially during moments like the 1776 campaign and the harsh conditions at Valley Forge. His image was built around strength under pressure, a leader who remained steady while others struggled. But when viewed through the lens of genetic reconstruction and AI analysis, that image begins to shift. The data suggests that beneath that outward strength, his body may have been under constant internal strain, managing conditions that were never visible to those around him. This doesn't diminish his achievements, it reframes them. Operating under prolonged stress, with underlying biological challenges, would have made every decision and action more demanding. By the time of 1799 death, the accumulated effects of years of strain, exposure, and vulnerability had likely reached a critical point. The idea of an unbreakable leader gives way to something more grounded, a person navigating both external pressure and internal limitation at the same time. This perspective connects his personal health to his public legacy in a way that had not been fully understood before. It shows that strength is not always the absence of weakness, but the ability to continue despite it. The deeper researchers looked into George Washington's DNA, the more his story began to change. Evidence tied to 1799 Mount Vernon and patterns seen in 18th century health conditions suggest his life was shaped by hidden biological limits. What once looked like sudden decline now connects to long-term factors that built over time. His strength remains undeniable, but it now sits alongside a quieter reality, one where internal struggles existed beneath the surface. The image of an untouchable leader shifts into something more human, more complex, and far more real.